Hello, everyone. We have a wide range of attendees around the world. I guess this will be the most international Grad Talk seminar. Thanks to Professor Adrian Bejan'a and his good reputation, distinguished professor from Duke University is our guest tonight. Thank you, Professor Bejan'a. Can you hear us?
Yes.
Okay, I want to make it short. I want to make as brief as possible because you have a long resume and a successful career. So Professor Bejan'a was awarded for the Benjamin Franklin Medal 2018 and the Humboldt Research Award 2019. His research covers engineering science and applied physics, thermodynamics, heat transfer, convection design, and evolution in nature. He is ranked among the top 1 in 10,000. I don't know how to 0.01% of the most cited and impactful world scientists, and top 10 in the engineering worldwide in the 2019 Citations Impact Database created by the Stanford University. He is the author of 30 books and about 700 peer-reviewed articles. He has a really high H index, more than 100, and more than 80,000 citations. The numbers are not enough to describe you, the professor. He received 18 honorary doctorates from universities in 11 different countries. He received many great number of awards, honorary membership, and the distinctions from the prominent research institutions and academies all around the world, including USA, Germany, Romania, Italy, Switzerland, Portugal, Japan, Hong Kong, Brazil, and so on. And recently from Turkey, he has been awarded with honorary membership and prize in basic and engineering sciences by Turkish Academy of Sciences, TÜBA, in 2019. Thank you, Professor Bejan'a. Thank you for being here with us. I guess we can start the presentation.
Well, thank you very much for the introduction. I have very warm feelings for Turkey, Istanbul, and Beşiktaş in particular. My first visit was with my wife there in August 1978, and I've been a frequent visitor since. Now we have a hiatus because of this import from China called the virus, but hopefully it will go back where it came from. I want to thank, first of all, Rector Tamer Yılmaz and also Zeynep Isik for inviting me to speak to you.
Yeah, they couldn't be here. I want to check the list, but they were in also an important meeting. They couldn't be here with us. They also would like to send their hello to you.
And I also send a big hello to my collaborator and co-author, Rector Bahri Şahin.
Yes.
Yeah, I think of him quite often. What I will show is a 27-minute video created with the help of Professor Ümit Güneş, who is currently hosted by Duke University, not far from my office. And after this video, I am more than willing to entertain your suggestions and questions, and also disapproval, if you wish. So here we go, and I hope you like it.
Thank you.
This lecture is about how to predict evolution. I will illustrate the power to predict by discussing a subject that is familiar to everyone, namely the changing designs of airplanes and helicopters. The more important message is that contrary to the impression that we get when we hear the word evolution out of biology, is that evolution is not entirely random. It is.
We have a sound problem, or is it only me?
We have some problem.
Professor Bejan, we are having a sound problem.
Yeah, he unmuted himself, I think. He muted.
If you unmute yourself, we cannot hear the video.
I see. Okay, fine. Can you hear me now?
Yes, clear.
All right. Sorry, I'll go back a little bit.
Yeah, a couple of slides back.
Repeated changes that impress us with a particular direction in time. My lecture is based on my most recent book called Freedom and Evolution. And first, why is this lecture about us? It is because everything that moves on Earth, including everything that surrounds us as it moves on Earth, does so because it is pushed. It is pushed by power. The power comes from engines, which are contrivances, natural or human-made, that convert heating into work, or work per unit time, which is power. And the power produced in this particular sketch, the power is exiting to the right, the heating is entering from the left, and in the blue domain, there's a population of contrivances, natural and man-made. The number of these flow architectures, these drawings, is immense, and these drawings are a combination of old and new, meaning that the contrivances have been evolving over time. This is only half of the so-called thermodynamics of nature. The other half is what I sketch here in green. The power produced by engines is destroyed immediately in the green domain, which is another world of flow configurations. The green domain that dissipates the power. I call them brakes. It is basically the flow, relative motion against the environment. The mover makes progress horizontally on the surface of the Earth because it displaces its immediate environment. No environment is willing to get out of the way unless work is done on it. So that's the big picture, meaning that the heating from a source, say the sun or food, is converted into power. The power is dissipated because of movement. And in the blue domain and in the green domain, there are flow configurations. They change over time. They change by themselves. They morph with freedom. And this is true of the geophysical world, meaning the air currents and oceanic currents, the animal sphere, the human sphere, and all of this movement visibly, meaning pictorially, is evolving into configurations that provide greater access. The name for this entire movie plot, is sustainability. This is where we come from. This is also where we're heading. And so we are not, nature is not a catalog of still images, as we might get the impression from the botany book, the zoology book, the anatomy book. No. Nature is movies on top of movies on top of movies, and then of course our minds that have the ability to remember these impressions. In 1996, I summarized this vision in one brief statement called the Constructor Law, which is that for a flow system to persist in time, and this is the definition of to live, or the definition of a live flow system in physics, as opposed to a dead one. that system must evolve with freedom such that it provides greater access to what flows. I illustrated this with three snapshot evolution of a river basin. The drawing is always arborescent, but from one frame to the next, the tree flows more easily. So evolution is the change in flow configuration, change after change with directionality that makes sense to the observer. And the one-word summary of the summary called the Constructor Law is that this is the definition of change, or the definition of time, which is a difference between new and old in physics. Now, with a law of physics, the human mind is empowered to imagine what will be. In other words, to come up with mental viewings that deserve attention and deserve respect, such as, for example, the law of gravitational fall. You know, in your mind, what to do and not to do when you're on the balcony. You don't jump, okay? That is the usefulness of the law. And so with the law, we unwittingly make predictions and we act next in our own interest. Here is the result of one such prediction. This is work from 2006 with a biologist, a colleague of mine, Jim Marden. We predicted animal locomotion everywhere by invoking the Constructor Law. We came up with the result, that the prediction that the speeds of all the movers plotted here on the ordinates should be proportional in a particular proportionality with the body mass raised to the power 1/6. Flyers are relatively faster than swimmers, but the relationship is the same. It's shown with a solid line for flyers, with a dashed line for swimmers. We collected all the data that was available back then and discovered that all the movers are in fact have evolved, meaning have exhibited in convergent evolution that was in fact predictable from the Constructor Law. And more recently, with colleagues from the Yıldız Technical University in Istanbul, I've shown that human-made movers, such as all the shipping, agrees with the swimmers, and so do all the flyers. In this older drawing, the flyers appear to deviate upward from the predicted theory. However, that is a wrong impression, because the airplanes are in fact flying through an atmosphere that's friendlier, meaning rarefied in comparison with the atmosphere near the ground where the birds are struggling. So when one adjusts for the difference in air density, then the airplanes are no different than the theoretical line. So success of this kind is an invitation to continue to rely on the law. Now, the reason why the human-made movers perform the same way as the animal is that we are a highly evolved animal species, which I call the human and machine species, because each of us is not a naked body. Each of us is encapsulated in contrivances, add-ons, artifacts that empower us to be obviously more powerful, yes, than naked. So in this sequence of three snapshots from a long time ago to our future, from the naked human to the human with the tool, and now a human with everything plus intelligence in the mind, but also artificial intelligence, the specimen, you and I, is becoming a more powerful one than yesterday. So now we're starting the the two examples of my presentation, airplanes are these biggest human movers that we have through the air. Here we have a panoply of the models of airplanes that have been adopted during their 6 or 7 decades of commercial jet aviation. You see a mountain of pictures. Some of the models are big, others are small. Over time, the bigger have been joined by even bigger models. But that's one trend. The other trend is that in every decade, for example, the past 10 or 20 years, the new models are arriving in all sizes. And the new that are big are few, and the many that are small, the small are many. So in every decade, we have a diversity of new models that vehicle humanity on the globe. The diversity is of two kinds. One is what I just said, that the sizes are not the same. We have few large and many small. The other one is that the two models of the same size, even when one is a copy of the other, are not exactly the same. And now I will look into this particular feature, which is, as you'll see next, also predictable. Every airplane is actually a flying house full of components, full of organs. Every airplane has engines. The engines have a size, which is different than the size of the airplane. From the Constructor Law, we're able to predict that the engine size should be about 1/10 in terms of mass, the size of the whole airplane. This compilation of measurements supports that prediction, and it is an important prediction because while predicting the future of the engine size on airplanes, it also answers predictively an observation from zoology, which is that the muscle mass on any natural flyer, a bird, is a fraction like this one of the whole body weight. Now, why should there be a proportionality between motor size and body size? That comes from a trade-off in the construction of the flowing architecture. Here, the motor is sketched by me as a heart. If one examines the organ, the heart, in isolation, one knows from thermodynamics that the heart is more efficient, therefore it destroys less useful power if its channels are wider, bigger. So a big size in the motor, also there's a tendency called economies of scale. Big size means greater efficiency. This would suggest that the best motor should be the better motor should be the bigger motor. But that runs in conflict with the interest of the whole, which is the airplane. The bigger motor becomes a bigger suitcase that has to be carried by the airplane, therefore more fuel being spent on simply carrying the organ. So from the conflict between the two trends, at the intersection of the asymptotes, arrives the let's call it compromise, where the best idea of what kind of an organ size serves the whole airplane the best. Here we learn one important thing, that the flow system in aviation is not the organ, such as the motor or the environmental control system. The flow system is the airplane itself and all the airplanes that follow it on the same route. That is the river of people that through human ingenuity is evolving toward greater and greater access. In the same way, with the Constructor Law, we've predicted that the wingspan and the fuselage lengths should converge toward a proportionality close to 1-to-1, as you see here in the cloud of data that has been racing upward from decade to decade. Also, helicopters, coincidentally, or I should say not coincidentally, have been converging in the same evolutionary direction. So here on the ordinate is the specific fuel consumption. So yes, over the years, all the helicopters have been evolving toward flying on Earth more and more economically. This is a compilation of the known models of the civilian helicopters shown in the white and military helicopters shown in black. Just like for the airplanes, we predicted and then validated the prediction that the engine size should be a fraction of the body size, that the engine size should be of the same order in terms of mass as the fuel load. The rotor length scale should be the same as the body length scale. Remember the proportionality between wingspan and the fuselage length. And here, the specific work per unit of fuel burned should be greater when the engine is bigger. This a very important piece of physics, which is predictable, which is called the economies of scale, is in everything that flows as a flow system and morphs with freedom. And with this, I bring up the other feature of diversity, which is the organization, which is called hierarchy. Hierarchy in aviation begins on the ground. On the left is the rectangular area of any airport, in this case, the Atlanta airport. It is a flow of humanity, that is people on the area, and every individual has an interest very similar to the neighbor, which is to get from any gate to any other gate, including the terminal. So the solution, which occurs to the group without participating in a city council meeting, is that the airplane area shape should be a particular shape. In this case, the shape is the one that you see, and it is such that the time spent by people who walk vertically in the blue, meaning along the concourses, should be the same as the time spent by the same people while sitting down or standing up and riding on the train. This is the balance or the harmony between a few large and many small, but it is actually a balance between the few fast and the many slow. In this case, the few fast is just one, and that's the train. This architecture, which is called hierarchy, is everywhere you look. For example, on terrestrially, on land, the freight moves on the surface of the earth the same way. In a few large and fast trucks that travel long, carrying the same freight as the more numerous, smaller, and slower trucks that or delivery vehicles that move transversely. The food chain is the same story in the zoological domain, and our way of illustrating that is shown here in another qualitative presentation of population size versus body size. These are the populations of all the flyers, from insects to the largest airplanes. This is qualitative data from zoology and the aircraft technology align themselves in this direction on a log-log plot. The point is that the hierarchy occurs in nature by itself, that is naturally. It just happens, just like the hierarchy of the river channels in the river basin. And so here is the river basin of people, vehicled by aviation. This is an image from satellites, an image of the condensation trails left by all flying aircraft 20 years ago. In the red are the most numerous movers. In the blue, the fewer, the point of the image is that even 20 years ago, on Earth, you could fly from any point to any other point. And just like the red blood cells in the human circulatory system, sooner or later, from any point A to any point B, the passenger has to travel through the two chambers of the single heart. The single heart is where this embryo was born. It was born in Europe and North America, and across the North Atlantic. So the vasculature will not change. It will remain the same, but all its blood vessels and musculature will become more robust. So the conclusion is that yes, movement is hierarchical. That means that fuel is consumed hierarchically, naturally, not uniformly, not in an egalitarian fashion, but in this distributed fashion, which is in fact demanded unwittingly by the interests of all the individuals who participate in this flow system. Even better, or even more, the hierarchical consumption of fuel turns out to be, this is empiricism, the same as the hierarchical distribution of wealth. I plotted here on the abscissa the fuel used per year by any country in the world, and on the ordinate is the annual wealth reported by the same country. So you see that fuel consumption hierarchy, which really means physical movement hierarchy, is synonymous with wealth hierarchy. The key here is the fact that along the yellow bisector, all the movers, in this case, live societies, which are live flow systems, are racing upward to the right. And that means that the future is one that promises not only greater wealth, but also greater consumption of power and more movement and more reach, and on other slides that I don't have time to present, also greater freedom. So there are a couple of conclusions to retain from this presentation. One is applies to research and academia, which is that theory, first of all, is the ability to see with the eyes of the mind. This activity is called idea, coming from ancient Greek. Theory is the complete opposite of empiricism. Empiricism is observing and then copying. Most of what goes on in science, and especially in engineering, is of the empirical kind. Examples are biomimetics and reverse engineering, where the designer looks around and gets inspired from what is observable. This technique of copying the observed, it works when the observer is actually equipped with the physics principles that underpin the occurrence of the observed object in the first place. More immediate, actually I say immediate payoff versions of biomimetics and reverse engineering are the outright theft of technology and plagiarism. These examples are everywhere if you pay attention. Here is one of the most famous. The highly successful Soviet jet fighter called the Sukhoi 27 from 1985 reappeared 22 years later from the People's Republic of China under a different name, J-11. And just to remind people of the saying that cheaters never win, the Chinese version is still not performing at the level of the original. So keep that in mind as you contemplate your own choice between theory and empiricism. Maybe your own idea is the one you should respect first. And so yes, theory is eminently valuable. because it gives you the power to predict, which is to know the future. For that reason, it fast forwards technology evolution. For those who are in your hands or around you, it is the most economical way of doing that, and it is testable. The theory is screaming to be tested, and if correct, then the theory is reliable. We are in fact relying on correct theories all the time, especially in aeronautics. Boundary layer theory is something that everybody these days uses without paying deserve the respects that need to be paid to Ludwig Prandtl. So that's the conclusion that should apply to all the academics who are in this conversation. If you'd like to know more, you should take an interest in my own evolution in this line of theoretical research. The Constructor Law began in 1996. It continued with a decade of textbooks. These are textbooks that are used in courses. They have proposed problems, solved examples, and lots of, obviously, illustrations that morph. So these are my textbooks on the constructal theory and design. During the past 10 years, I've made the effort to reach a much wider audience, which means everybody, especially young researchers who are curious about ideas, curious about making a contribution in their lives, and who are totally disinterested, meaning they are not competitors. They do not enter the scientific debate or correspondence with a chip on their shoulder. So to the young in the audience, maybe even to your children, I suggest that the way to start reading about constructive law and theory and design is to start, as usual, with the best idea, which is try the simplest first. And that is to pick up my most recent book, Freedom and Evolution. Okay, that was the end.
Thank you, Professor Bejan. Okay, now we can have the questions, comments, any contribution. And
well, let me say first, I'm delighted to see so many of you and to recognize a lot of you. I'd like to say hello to everybody, but also to give everybody a hug, because seriously, you are showing up from all the expected and unexpected places. And I like that. Thank you.
if you have any questions or you want to say something, you can raise your hand because we have a huge crowd.
We have a question in chat, and also there is a raised hand. We can start with the chat one if you want.
Okay, Nadir Hocam, if we can unmute, maybe he can read his own question. Nadir Hocam, thank you for this informative presentation. I'm trying to read the question from Nadir. Based on the results, the body mass of the movers make a model which is in accordance with the constructional theory. The question is, what can be the effect of, let's say, smart and conscious bodies with an effective interconnection skills with each others on their motion pattern compared to the first group of movers in accordance with the constructional theory?
Well, if the bodies that were mentioned in the comment are so intimately connected, then that cluster of bodies constitutes the flow system. That's what's happening on every airplane. The larger number of passengers obviously fit that way inside a bigger mover. But even without an airplane, the the cluster of these tightly connected individuals, each of them a flow system, the cluster itself becomes a larger flow system that will move in accord with what I just showed to be true for any mover, small and large. And what I said is illustrated every moment you look in the sky and you see a flock of birds. The flock of birds is that tightly connected cluster. The birds are actually in constant communication. They form a unit, if you want. And the better communicating this unit, the faster it moves, and the safer it moves, and the better camouflaged it is, and on and on and on. And well, meaning it becomes more powerful. That's what happens. That's the importance of size in nature. Size matters. And you get to see the physics behind that idea by looking at locomotion, which is palpable and testable.
Thank you, Nadir Hocam. I hope you get the right answer. Do we have any more questions?
Yes, we have a raised hand, Abdul Rahman.
Abdul Rahman, yes, we can unmute Abdul Rahman.
Yes, hi, Professor Bejan. This is Abdul Rahman, your former student. I got a question for you. Thank you for this presentation. The question is, now people are moving to what we call a decentralization of energy systems, means they are moving from large, which is more efficient based on your conclusion, to a smaller system or smaller substations. How this is going to affect the efficiency of large systems?
Well, the so-called decentralization is in fact not the movement from the large, meaning abandoning the large and then everybody being small and kind of the same. No, the trend is toward a more and more natural hierarchy. And it is true that historically, with a new technologies such as the technology of power generation and distribution, yes, in the beginning, the technology developed from singularities, famous power central stations and power centers and so on, in every domain, not just the production, but also the use. And then, excuse me, then with more and more power being produced and more of it reaching users, in other words, with a population of users that becomes more advanced, more affluent, and more powerful, of course, the ability to design a system that's better connected to the smaller and smaller scales, that improves. And you see that everywhere you look in everything that's present, not just power, but information, education, obviously food and medical assistance and everything else. That's the trend. That's in fact just one observation about the entire history of civilization.
Thank you, Professor.
Thank you, Abdul Rahman. Thank you. Do we have any more questions and comments? I guess everything is clear.
I hope not. I hope not.
We have a question here, I think.
Not a question.
Okay.
This is just a statement. I have to thank Umit for inviting me for this presentation. It's been a while that I've seen Adrian's face, and I'm very happy to listen to the lectures. And every time I listen to him, it brings back memories of Duke to me, and and the reason why I have to still continue working on constructor theory. So, and I'm happy to have listened to the lectures. And Adrian, thank you for the wonderful lectures.
Thank you. Thank you, Tunde. Where are you now?
I'm in Cape Town. This is this is from my room, from my
Cape Town.
from my study room.
Oh, okay, Cape Town.
Yeah, Tunde.
South Africa is that?
Tunde is a prominent full professor in South Africa and also a magnet for students.
Oh,
and a very impressive, very impressive academic, and I'm very proud of him. And
Thank you.
very, very good for us and for Africa in particular. And I miss him greatly. I'm sorry you didn't come to Duke this summer.
Yeah, the COVID thing didn't allow me. In short, I'm losing the funding for that trip, unfortunately.
It's okay. That means that the world will come to you in this case. Yeah, very good care. And,
Thank you.
And good luck in the African Cup of Nations. Yes.
Yeah, thank you very much.
thank you, Tunde. And do we have a question from Marcy?
I think he was writing, or he's writing.
Or you can take the microphone, Marcio. If you have any question, we can unmute him, hocam. We have a guest from South Africa, from Brazil. So it's really an international, intercontinental seminar. Thank you. Okay, from Claudia. Maybe Claudia would like to hear, ask the question for herself. Can we unmute Claudia, hocam? Or is this a question? Yes. Thank you so much. I'm reading the question from Claudia, hocam.
Okay.
Professor Bejan, thank you so much for your presentation. I'm studying construction law under the supervision of Marcelo Herrera, sorry for the pronunciation. You have applied construction law to the economy before. We know that economies of scale bring greater efficiency, but considering how excess of the complexity can lead system to collapse, do you believe there is a trade-off for the size of societies and economies like there is in the size of bodies which move through space?
That is a very good direction in which to think. Before this question, I knew the answer has to be yes, but not because of this trade-off that Claudia is suspecting. From my point of view, there has to be a moment of the arrival of the feeling that enough of this, meaning enough of exploiting an idea that works, because in the direction of implementing this idea that okay, larger is better and so on, or any other idea that's beneficial in design, along that route, as the idea becomes older and older, or let's call it mature, in that direction, the improvements are decreasing significantly. This other piece of physics is called the diminishing returns. And so if you get caught on that path, you, the designer or the maker, the whatever investor and everything, are lucky enough to be possessed by a new idea that's fresh and promising, and that terminates the travel on the old path that had become mature. So any good idea that becomes mature is in fact inviting you to fall in love with something new. That's what I thought before this question. This question is, I think, worth exploring as a brand new question, and I haven't worked on it. Okay. So.
Thank you, Professor. I hope Claudia is happy with the answer. So we have a question also from Marcio Cesar. He is saying that, have you already analyzed the brain from human and other animals, how the information flow connections, including numbers of the neurons?
Well, I haven't, but I haven't really worked on it, but I've been thinking about this from a child, because my father was a veterinarian, and he was, every time he was cutting through an organ, he was talking, and
so you have
the configuration is the same as cutting through the lung of the pig, and obviously the same as what was outside the window, which was the Danube Delta. All of these things were one thing in my early imagination. So these days, meaning since 1996, I get frequent comments from readers about the architecture of the brain being constructal. And my immediate response is that, yes, that goes without saying. It is, in fact, it had to be because the flow architecture in the cranium is precisely the way my lecture began, which is movies on top of movies of flow, tree-shaped flows that morph to connect at any time, any point with all the other points. And how do you achieve that if not through a, well, obviously impossible to draw, superposition of bundles and bundles of trees. So that's the way that I sleep well at night as I think about the brain, okay? Meaning I understand it, even though it's not my domain. We have to be very, in fact, science is teaching humility in the sense that you understand where you are at peace with expecting the immediate future, but at the same time, you are not so sure because it is the duty of others, to the duty of those who really know, not just anatomy, but the physiology and the human architecture, to jump in and attack these questions from theory, that is predictively, not data, you know. That's my my view of the subject.
Thank you, Professor. Do we have any more in the chat box? I cannot see any question. Hocam, do we have any raised hands?
We don't have raised hands, but there is a question in the chat.
Greetings and
from Mike.
Any question, Mike?
Mike.
Okay. If one finds a dendritic pattern in their research, should they first explore the constructal paradigm?
Yeah, well, first of all, I predict that the dendritic pattern that's discovered in that research happens because the object that's being studied is a flow system. If that is the case, then clearly the observation of the arborescent flow architecture is should have been expected from a person equipped, obviously mentally, with the Constructor Law. However, the person who is not aware of the Constructor Law and discovers such a thing is encouraged to question why this observation happened and why it is so similar to to other observations. And then that person enters the let's call it intellectual arena that I entered a few decades earlier, and an entrance that made me happy. So I invite people to question all the time, to question what they observe and what they hear. Absolutely. Yeah, and that includes to question the professors and the politicians and everybody else who makes noise.
Thank you, Professor Bejan. We have also some comments from the students. Maybe they will email to you later on. If we do not have any more questions and comments, I would like to thank to Professor Adrian Bejan. It has been a privileged pleasure to have Professor Bejan in our Grad Talks and giving us this quite international seminar to have. Thank you for, he has a limited time and tight schedule. He has given his time for our seminar. I would like to thank on my university's behalf and the rectorate, Professor Tamer Yılmaz and Dr. Zeynep Işık, also Professor Bahri Şahin and Ümit Güneş Hocam. Thank you for getting help us to organize this seminar. Any more words from international attendees to say something? Or if not, I guess we can finish our seminar. Thank you, Professor Bejan. Thank you.
Thank you, and thanks to everybody.
Thank you.
Take good care.
Thank you, everyone. See you next week for our next Grad Talk seminar. Good evening.